so outcome R1 begins with the first question, which is drawing a graph to represent a situation. Okay, now a lot of you didn't notice there was just one little problem to start with this, and that is that she starts the walk home from school. So she's already at school. She's 3.5 kilometers from home. And this graph, the y-axis, asks us for the distance from home. Hey, wait a minute. She's starting here at 3.5 kilometers away from home. Okay, so 1 kilometer in, she's going to have walked for 20 minutes. So looking at the x-axis here, or the t-axis for time, 20 minutes in, she's walked 1 kilometer. She started 3.5 kilometers away from home, and she still has about 2.5 kilometers left to go. Connect the dots, and we are off to the races. Okay. If you connect the dots better than that, that's fantastic. Okay, so then she stops to talk to her friend. Let's see. So she stops to talk to a friend, and she talks for 10 minutes. So 10 minutes, she's talking to a friend. So 10 minutes, she makes no progress in her walk home. She continues to be 2.5 kilometers away from home. Okay, and then continues walking at the same pace. Okay, so the same pace is essentially the same slope or rate of change. Originally, her original pace over here in black, she was going down 1 and to the right 1. So she'll continue in that way, and there we go. After 15 minutes of same pace, she's now 45 minutes into her trip, and it's been, she's still got about 1.75 kilometers left. Okay, next, go back to black. So 15 minutes later, she stops for 5 minutes to rest. Okay, so 5 minutes of rest. So we need another new plateau there just for 5 minutes. Okay, finally, she starts walking at the same pace again. And after 15 minutes, okay, so stop there. So 15 more minutes at the same pace. That's down 1 and to the right 1. So down 1, to the right 1, down 1, right 1. Okay, then what does she do? Well, final thing here is she runs for 5 minutes until she is at home. So 5 more minutes is all it takes her to run what remains. And there, this massive trip home. 70 minutes later, she's made it all the way home. That's question 1. Next, question 2. Here we go. So the graph shows the volume of gas in a car as a function of time. Describe what's happening in each of the line segments. Okay, segment EF, that's over here. You notice that the volume remains constant. It's a full tank for the entire hour there between E and F. So we could say for 1 hour, no gas is used. And you could say this a lot of different ways. You could say that the engine is not running, or you could say they've parked and gone for lunch, or whatever you want to say for that. Okay, AB. That's a 3-hour period, so we could say for 3 hours, they burn gas. And you could specify that if you like. I guess they burned from 70 is the volume they started with, and they finished here at 40. So let's say 30 liters. Okay, and you could say this in a number of ways as well. And the last segment here is D to E, which is this sudden spike up. Okay, so what's happened here is they filled the tank, right? They had 0 liters essentially at the end of this journey, and they filled up suddenly to E at 70 liters, so we could say they filled the tank. And a variety of answers can be accepted for this question. Okay, so here's the last page of outcome R1, and it's a couple of domain and range kind of questions. This is great. So the domain we should keep in mind is usually the x-axis. So we have the domain down here. And I'm asking you for the domain. Specifically, I'm not just saying, I don't want you to tell me it's t or time. I want you to tell me all the t values. So that would be 30. Here is halfway between 30 and 60, 45. Let's see, that's 75, 90, and 120. That's the domain. Those are all the domain values. Now for the range, that's usually this axis here. So we've got a bunch of C values or cost values for the range. And again, there are 5 different values that I should have here. By the way, those are 1, 1.5, 2.5, 3, and 4. Okay, moving right along. The next graph is domain and range as well, but this time it's a little bit different. Okay, we have time, which I'll call t in our domain, and we need to say, well, what are all the t values? But you notice there's lots of them, 0 and 5 and 10 and 15 and 20 and 25 and 30, and all the numbers between there. So we could write it this way. The lowest t value is 0, and the highest t value is 62.5. And so the complete set of all t values for our domain are all the t values between 0 and 62.5. For the range, we could talk about speed. I'll use v for speed for some reason, since that's what the science guys tend to usually use. You can ask them why they do that. Let's see. So the highest speed that we get is at 140, and the lowest speed is all the way down to 0. Okay, put it in these fancy brackets again, and we're done. All right, one last question here. A relation is given by a set of ordered pairs. Represent this using an arrow diagram. This is an arrow diagram here. We'll put all the values over here, 2, 1, 4, and 7. Those are all the domain values. All the range values, well, there's just one of them, just 3. And now connect with arrows pointing from the domain to the range. Okay, and that's an arrow diagram for you. All right, that's it for R1. Go ahead and take a look at the other videos as I make my way across the US on my way to Japan to take a look at all the other solutions. Thanks.